Hello, good morning. Myself A. Venkat Subbareddy, Assistant Professor of Electronics and Communication Engineering at G. Pullareddy Engineering Course, G. Pullareddy Engineering College. So this is Basic Electronics Engineering course. So in this I will discuss about digital part. So I can discuss in this session how to represent binary numbers, how to represent the binary numbers. So the binary numbers are grouped into two groups. One is unsigned binary numbers, another is signed binary numbers. So the unsigned binary numbers means only positive numbers, there are no negative numbers. So signed means both positive and negative. So how these numbers are represented in binary. So if I have considered with the unsigned numbers, so the unsigned numbers they contain only the magnitude of the number. So because all the numbers are positive, they do not have any sign because all the numbers are same. So there is no inclusion of the sign of that number. So that means all unsigned binary numbers are positive. As in decimal number system, the placing of positive sign in front of the number is an optional one for representing positive numbers. So in the unsigned numbers, there is an option of placing a plus sign in front of that number because it contains only positive numbers. If it is a signed numbers contain both the sign and magnitude of the number. So generally the sign is placed in front of the number. If you observe in any decimal number, the negative numbers are represented with the minus, which is placed at the front of that number. So we have to consider positive sign for the positive numbers and the negative sign for the negative number. So plus we can place before positive numbers and minus sign I have to place before the negative numbers. Therefore, all the numbers can be treated as signed numbers if the corresponding sign is assigned in front of the number. So that is, in front of any number is placed the sign, then it will be treated as a signed number. If the sign bit is 0, which indicates the binary number is positive. So if the binary number is positive, we need to place 0 as the sign bit. Similarly, if the sign bit is 1, it represents a negative number. So when the number is negative, the sign bit is considered as 1. So if I am representing any unsigned binary numbers, so already told the bits in the unsigned binary number represents only the magnitude. There is no position of sign. That means if the unsigned binary number contains n bits, then all n bits represents the magnitude. Since it does not have any sign bit, all the n bits represents the equivalent binary number of given decimal number or the octal number. For example, if I consider the decimal number as 108, if I represent it in the unsigned binary number, first I need to convert that number into equivalent binary. So 108, the equivalent binary is 1101100. It is its equivalent binary value. So if I have to represent this in the unsigned binary number, I can just represent with this binary equivalent. So it is having total 7 bits. All these 7 bits, the magnitude of the number, which is 108. That is how I can represent for the unsigned numbers. All the bits are represents only the magnitude. Then if I have taken with the representation of signed binary numbers, this is the basic procedure to be followed. Most significant bit, simply call it as an MSB of the signed binary number, is used to indicate the sign of the number. Hence, it is also called as an sign bit. So the MSB, that is the leftmost bit of that binary number, is always indicate the sign of that number. So hence that bit we will call it as an sign bit. The positive sign is represented by placing a 0 in the sign bit position. Similarly, we have to place 1 as a sign bit for the negative numbers. This to be followed for representing positive and negative numbers. If the signed number contains n bits, the n minus 1 bits only represents the magnitude number. Since 1 bit MSB is reserved for representing the sign of the number. So out of those n bits, n minus 1 bits are used to represent the magnitude of the number, and the remaining bit, that is MSB bit, is reserved for the sign. There are 3 types of representations for signed binary numbers. The one is sign magnitude form, another is 1's complement form, third is 2's complement form. So these are the 3 representations of signed numbers in binary. This is one of the important point to remember. Representation of a positive number in all 3 forms is same. If I have taken any positive number, if it is represented in any of these 3 forms, will be the same. Only it is different for the negative numbers. But only the representation of the negative numbers will differ in each form. So if I represent the negative number in any of these 3 forms, all are different. They are not same. So we will see how these negative numbers are represented in these 3 forms and how they are different. But for positive numbers, all these are same. We will see one by one. So if it is in a sign magnitude form, the MSB is used for representing the sign of the number, and the remaining bits represents the magnitude of the number. Consider a positive decimal number, that is plus 108, and its corresponding binary number is 1101100. Since it is a positive number, so the sign bit is 0. So this plus 108, so I can represent it in the signed binary number as, so these bits represents magnitude and this represents the sign. So the magnitude is 1101100. I have to place the sign bit in front of this number, that is 0. Since it is a positive number, I can place that sign bit as 0. So this is the representation of number in sign magnitude form. So consider if it is a negative decimal number, that is minus 108. We know the unsigned binary representation is same, that is 1101100. So since it is in a negative number, so consider the sign bit as 1, so which is placed at the leftmost side of the magnitude like this. So this is the sign bit and these all bits are magnitude. So in this case of 108, so if I am representing in the sign magnitude form, it requires total 8 bits. For unsigned 108, so it requires only 7 bit. That one extra bit is because of this sign bit as added along with the magnitude. So that's why the signed binary numbers requires more bits compared with the unsigned binary numbers. And if it is in a ones complement form, so the ones complement of a number is obtained by complementing all the bits of the signed binary number. So how we can represent the signed binary number in ones complement is, the ones complement is obtained by complementing all the bits of the signed binary number. So the ones complement of a positive number gives a negative number, or ones complement of a negative number gives a positive number. That means if we perform 2 times ones complement of a binary number including sign bit, then we will get the original signed binary number. So the one time if I have given the positive number, if I am complementing that positive number, it gives negative number. Then again this negative number I am complementing, then I will get original given number. So that is by performing 2 times ones complement, I will get the again original signed binary number. Then how you can represent the signed binary number in ones complement form? So consider the negative number, it is minus 108 and its binary representation is 108. It is the sign bit, all these are the magnitude. If it is 108 plus 108, the sign bit is 0 and the magnitude is 1101100. So I can first obtain the ones complement by complementing all the bits. If complementing means if the bit is 0, then convert into ones. If it is ones, and convert into the zeros. So that is called as an complementing. If it is 0, convert into 1. If it is 1, convert into 0. It is having total 8 bits. The MSB of this number is 0, which indicates a positive number. So replace zeros by ones and ones by zeros in order to get the negative number. So this position is 1. So here it is 0. Here it is 1. So convert into 0. It is 0 in the given original number. Convert to 1. Here it is 1. Convert to 0. Here it is 1. Convert to 0. Here it is 0. Convert to 1. Here it is 0. Convert to 1. So this is the ones complement. So that is written over here. This is how we can represent the given negative number in ones complement form. Then for the twos complement form, twos complement of a binary number is obtained by adding 1 to the twos complement of the signed binary number. So for finding out the twos complement form of a binary number, first find out the ones complement of that number, then you have to add 1 at the LSB position or at the rightmost bit. So 2's complement of positive number gives negative number, then again 2's complement of negative number gives positive numbers. We are including the sign bit during the conversion. That means again if you are performing 2 times 2's complement including sign bit, so you will get original signed binary number. Again we will take the same number, that is minus 108. Its binary ones complement we already did in the earlier slide, that is 1 0 1 0 0 1 1. So for this I have to add 1, so that is 1 0 0 1 0 0 1 1 plus 1, so I will get this. So that is 1 0 0 1 0 0 1 1. So I can add 1 at the LSB. So it is 1 plus 1. So I will get sum as 0. I will get carry. So 1 plus 1. Again sum as 0. Carry as 1. So 1 plus 1. Sorry, 1 plus 0. 1. So remaining all are, we will write down it as it is. 0 1 0 0 1. So which is same. That is 1 0 1 0 1 1. 1 0 0. So which is the 2's complement of minus 108. So you can observe this is the 2's complement of 108 and this is 1's complement of 108. So all are, both are different. If I had taken the sign magnitude of 108 minus 108, so I got it as an 0 1 1 0 1 1 0 0. Sorry, 1 1. So this is sign magnitude representation of minus 108 in sign magnitude form. This is 1's complement, it is 2's complement. So you can observe all these three are different for the negative numbers. All these three representations are different for the negative numbers. Thank you.